So this is Algebra 1, Semester 1. It's a unit called Systems. It's the 4th unit, and it's a lesson called The Solution in Systems Practice. It's the 2nd lesson. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So what we try to do, and I've tried to do this on a regular basis, although I don't do it every time, is try to show you where those notes are. They're a little hard to find. So here's the actual website name, creatormath.weebly.com. You're going to type that into Google, and hopefully you can get to this home page. Looks like this. So if you have any questions on your composition book, all right, then please go ahead and scroll down to this home page here. All right, where it says composition book, please follow these directions. And follow these, watch all these videos, follow these turn-in dates, put things where they belong, and put the notes on. There's no reason you shouldn't have a 90 to 100% on that comp book. Now we're going to go to the actual class tab, or in this case, it's the one we're making a video of, right? So there's at least 4 things under the tab of the class. The vocabulary, the practice problem sets, the videos we're making like right now, and the notes, and also the pages on which where all those things go in your comp book, right? So first, if you're not getting 100% on your vocabulary practices, then you may not know there's a complete PDF with all the vocabulary we use for the entire school year right here. You can download to your device and you can search it. Just Google how do I search a PDF from whatever type of device you're using. The directions are a little bit different for each. Next, we're going to go to the semester we're in, or in this case, the video we're making. So we're going to find that semester. Don't be in the wrong semester, or otherwise you won't find anything that we're working on. Okay, so in this semester here, there's a table of contents. It's so important I've asked you to write it in its total or entirety into pages 2 through 6 of your composition book. Why? Because it has all the page numbers of where everything goes in your comp book. And of course, you're going to watch the video how to number the pages of a comp book on the prior home page. Then once we're here on the right semester, we're going to find the unit we're in. So this unit is called Systems right here, and we're going to do Systems. Here are the different lessons. We're in lesson number 2 this time. So lesson number 2 right here, the solution in systems. Here are the page numbers on which the notes go in your comp book. Please don't take this video's word for it, but go back and find the original table of contents at the time you're watching this video. These page numbers probably, maybe, will have changed. So here are the notes. This is the problem set we're doing right now, and then the video solution will be linked here. So we're going to click notes. Sometimes I have to click this twice, you guys, to get it to open. And there you go. It sharpened up right away. Copy these notes onto the pages of your composition book, and it's talking about what is the solution. The idea that the solution is, first of all, what a system is. A system are 2 graph lines on a single graph. And what we're really interested in is the intersection here. That's called the solution. At this point, the answer to both equations is exactly the same, and we find that very fascinating, and it tells us certain things about the break-even point. So in preparation for those discussions / what that means and problems using it, we're going to practice here a little bit with a problem set. We're going to find a solution to ours and then plug them in and prove them. And that's what we're going to do in the problem set. Make sure you got system of equations and solution in your notes, and let's look at the actual problem set now. So the first one is, what is a system of equations? A system is 2 or more equations graphed on the same graph. All right, what is the solution to a system? It's where the 2 graphs cross or intersect. That is, they have the same solution at that point. So we are going to go through the same list of problems we did in the prior lesson. All right, so what we're going to do is talk about a little bit more this time from an algebraic standpoint. Go back and watch the last lesson. We went ahead and graphed each one of these, right? So we proved that this was intersecting at 1, 2. So just to remind you how that works, let's go back here, go to Desmos, and we're going to work on plugging in x plus 1 and negative 2x plus 4, x plus 1 and negative 2x plus 4 right here. negative 2x plus 4. All right, right there. So here's our intersection. We're proving that it's here at 1, comma 2, so we're okay with that. Now the question is, can we prove that in terms algebraically? So what do? Start with the first one, y equals x plus 1. That's right here, right? We have that x is 1, so we have a 1 here, and we have that y is 2. So does 2 equal 2? Check. So algebraically that's proven, right? Let's do it with this one too. Y equals negative 2x plus 4. So this is what you're going to work out. You're going to do these two in your comp book along with these answer sets, which we have already. And so we're going to take the x of 1. So let's put a 1 in here times a negative 2 plus a 4, and that's, we have a 2 on this side for the y. Negative 2 times 1 is negative 2. 4 minus 2 is 2, and 2. And sure enough, so this answer solution, why is it called the solution of two equations? Because at that point, that intersection point right here, the x and y input and output are exactly the same for both, and they share a solution set at that point. Okay, so it's called a solution. So we have 3 more to do, and we're just going to repeat this process. We know it's 2, 7 here, but let's go ahead and prove it using this one. Let's say y equals 4x minus 1. Right, there we go here. Y equals 4x minus 1. And we have negative x plus 9. So 4x minus 1 and negative x plus 9. Here's our intersection right here. Let's click on it twice. 2, 7. That confirms that. Now let's go ahead and try those values. So y is equal to 4x minus 1. We have an x of 2. So the 2 goes in here. The 4 is here, minus 1. We're just filling in. The y is 7. 4 times 2 is 8. Minus 1 on the right and 7 on the left. 8 minus 1, sure enough, is 7 on the right and 7 on the left. Check. Let's try this one here. Y equals negative x plus 9. So the x in this case is 2, so negative 2 plus 9 equals, and y would be 7 here. Okay, so 9 minus 2 is 7 equals 7. Check. All right, let's do it again. Let's go ahead and graph these two. So we've got 2x minus 3. And we've got negative x minus 9 in this case. Can I just do the minus? Let's just change that. Let's hit home to find out where that location is. Sometimes we can't find it without hitting that. So negative 2 comma negative 7, that's check. And this is our correct answer in these terms. Now let's plug in the values to see how they go. Y equals 2x minus 3, and y equals negative x minus 9. Then the x is negative 2, so 2 times negative 2 minus 3, and the y is negative 7. This is 2 times negative 2 is negative 4, minus 3 gives us a larger negative number, or negative 7. Sure enough, that's equal to negative 7 on the left. Check. Y in this case is negative 7 is equal to a negative 2, so a negative 2 minus 9. Negative is positive, so 2 minus 9. And 2 minus 9 is a negative 7. This equals negative 7 here. Check. So that works too. All right, let's do it one more time. Now we get some fractions involved in the graphing, but that's no big deal. We just say 1 divided by 2 will give us the 1/2 here. X, let's go to the right, put an x, and say minus 3. There's 1. And let's say negative 2/3 x. So negative, let's put a 2 divided by 3 in here. Negative 2/3 x minus 9. So that looks like the same one. Let's check to make sure that we have the same solution. So this one I don't like at all because look how messy it is. We're going to use our calculator for this, but it's this answer right here. All right, let's see if we can do it with this one. So this is a little bit different than the others. Let's go y equals 1/2 x minus 3. Okay, so y in this case is a negative 5.571 equals, and we're going to use all the decimals here, a negative 5.143, which is x, times 1/2. Sorry, I put them in reverse order. Apologize for that. So this one's going to stay the same. We're going to use the calculator for the right and see if we get negative 5.571. All right, let's pull this up and go here, here. Clear this out and say negative 5.143, 0.143. I'm going to put it in a parentheses because that's the way it is. Let's parentheses this. Will it do it? Come on, get out of there. So divided by 2, because that's what times 1/2 is divided by 2, minus 3. And we get a negative 5.5, negative 5.572. Now, why did we get a 2 here and a 1 there? So this is what's called a rounding error, right? So we're going to let that go because we're only using this many decimals. In fact, if we were to cut this one off here and cut this one off here, then we'd have the 2 the same here. But that is a rounding error, but that's okay. All right, we can expect that, in other words. So let's go ahead and do it one more time on the other side. So y equals negative 2/3 x minus 9. Y is negative 5.571 equals negative 2/3 times negative, wait, did I put in y? Here's y, negative 5.571, check. Now I got to put in negative 5.143, negative 5.143 times minus 9. Okay, so negative 5.571, and let's clear this out. Let's say 2/3. So this is a negative 2 divided by 3. I'm going to put that in a parentheses. That's my 2/3 times negative 5.143 times negative 5.143 and minus 9. So we get a minus 9 in there. Let's make sure that's right. And we get negative 5.571. And in this case, our rounding error worked out, but we could be willing to remove that last decimal to say that it works. But it works in this case, and it works in this case. Okay, so proving that where those two lines cross, back to here, right here, at that solution, they do indeed share the same x and y values, those two equations. And that's what we're proving and examining in this lesson, all right? Make sure you're getting the right title for the problem set you're in of the video. This video is titled Algebra 1, Semester 1. It's a unit called Systems, number 4. And it's a lesson number 2, the solution in the systems practice on creatormath.com under the Algebra 1 tab. Hope this helps.